This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Become an autonomous digital enterprise and your business can achieve A-game status. Intelligent predictive systems, effortless automation, and technology and people working in harmony. This is the Autonomous Digital Enterprise. Visit bmc.com/agame for more information.
This is Priyanka Raghavan for Software Engineering Radio. And today we're going to be talking about software bugs and why it's okay to ship your software with bugs. And my guest for today is James Smith, who's the CEO and co founder of Bugsnag. And James is an entrepreneur, he's also a software engineer, and he has a broad base of experience. He's very passionate about building great products, growing teams, and scaling infrastructure with data. And he's also developed many open source projects like LoopJ, which is used by companies such as Twitter, Pinterest, and Trello. So welcome to the show, James.
Thank you for having me, Priyanka.
So let's jump right in. We want to talk about, bugs. So in our industry, as we've moved from many different software processes, like, going from, back in the day, waterfall to, now where we are with agile. And then we have all these sort of, continuous integration processes like, we have DevOps, DevSecOps, Biz DevOps, all of these things with the intent of, reducing bugs before you ship the software. So we're curious to know why you think it's okay to ship software with bugs.
Yeah, so I think, to be clear, I think it's a really, really good idea to reduce bugs before you ship your software as much as
Okay.
possible,
hmm
especially when it comes to best practices like just adding linting and having CI/CD run your tests and builds every single time.
Right.
But the reality is that it's a trade-off. If you want to be competitive delivering your features or your product to your customer base, you have to figure out, well, would it be more valuable to deliver those features to my customers quicker? And so one part of this question is, will reducing the time that we spend on the human-powered QA or test coverage or code coverage get us to market quicker? But in reality, I actually think the big reason why it's okay to have bugs slip through to production is because there's really nothing you can do about it. And so even if you have the absolute best, most locked down, 100% code coverage, linting, and you run your test every time you type a character on the keyboard, in reality, you cannot test every single experience that your customers are going to have.
Right.
And this is particularly true in the client side mobile browser environments where there's tens of thousands of different Android phones on the market.
Right.
And you're not going to be able to run your software on every single device with every piece of data coming through every flow in your software. So
Right.
it's more of a reality, I think, that you can reduce the egregious bugs and the worst case bugs, but some will absolutely slip through. And then sometimes it's okay. Sometimes it's okay to have bugs slip through to production so that you can get that feature out to market quicker. One really good example of that, if I remember rightly, when a few years ago, Lyft and Uber were both working on their shared rides experience. So before this launched, you had to ride on your own in a Lyft or an Uber. And it used to be called, was Uber Pool and Lyft Liner, it used to be called. And it turns out that they were both working on it in parallel. And Uber launched theirs before Lyft launched theirs. And then Lyft went out and launched it the day after or within a week of Uber having their feature launched. And Uber got all the press. Uber got all of the excitement about it, all the buzz about it. But Lyft were like, damn it, we were ready. We were right there. We've been building it. Obviously they're different features, different experiences. But sometimes it's okay to trade these things off.
Right. I mean, yeah, because you have to get to market quicker. So yeah. Okay, so that's so you're saying it's good to do a lot of this, static code analysis, unit testing, whatever, your early load and security testing, all that is good, but you can't be perfect. Is that would that be right if I were to sum it up?
That's right, yeah. And I'm oversimplifying here because there are
Okay.
environments like
Right.
you're not if you're building a space shuttle or medical software,
Sure.
situations where you're going to get in big trouble. People might die, or billions of dollars might get lost if you don't catch that bug. You want to be
Right.
a lot more careful about this and take a different approach. But if you're doing web software that you're delivering on a regular basis, you can hotfix and patch,
Right.
or even apps delivered on a phone or desktop that you can update. Yes, you can be a little bit more. You can get
Okay.
away with a lot more.
Okay. But like I was also curious in your experience, there are these certain types of bugs which are sort of, primarily come from, say developer being a little lazy and, you're not doing enough checking and those kind of things. What are your, what's your take on that? I mean, I guess a lot of these kind of, early testing helps with that, right?
Yeah, it really depends on the language that you're working with. It's actually a really
Sure.
big variant on this between languages. There's modern languages like Swift that try to force you to not use uninitialized variables,
Hmm.
and this is a really common cause of problems in other languages like JavaScript
Right.
or Ruby even, or Java.
Hmm.
And I think that I would argue that it's probably not. I know what you mean, though. It's not developer
Hmm.
laziness. I think it's more lack of care or lack of understanding. I think that you'll see that the junior developers, the people who've been in their career for only a couple of years, are going to be the ones racking up the null pointer exceptions and
Right.
uninitialized variables.
Right.
But there are ways around this, and I feel like the engineering organizations, it's the job of the engineering managers and the leaders on the team to set up the IDE rules and the linting rules and the checks to make sure that those things get caught. I think most people listening will have done this exact same thing before, and that is sometimes you want to just get the thing to work because you're like, right, if I just connect this last piece of the puzzle together,
Right.
I can see it doing the thing that I want it to do. And
Yeah.
sometimes along that journey, you want to collect all the pipes together, and you're not gonna put in all of the perfect exception handling
Right.
or the weird edge cases. And so that's fine as long as you come back and clean it up and make sure that you handle these things. And yeah, some languages handle this much better than others. There's a whole wave of modern languages that are trying to make language features that stop bad behavior from developers.
Right.
But even outside of that, I think in IDE land, you can write Java code in Notepad if you want, but most
Hmm.
Java developers are using some kind of IDE.
Hmm.
And when you're using an IDE and you're calling a function that will throw an exception, it's
Hmm.
gonna generate that code to make sure that you're handling that exception correctly. And so most IDEs have features baked in to say, hey, heads up, don't forget you need to do this. So
Right.
I think it's lack of experience, lack of care, maybe getting excited about delivering these features to your customers or seeing it work yourself.
Right.
But there are definitely ways around it.
So, which actually, since we're talking about languages, is there like, do you think there's, do you see more bugs in certain languages? Is there some,
Oh yeah,
analysis?
absolutely.
Okay.
We haven't. You know what? We should do a report on this now. We have plenty of data on this. We should definitely run a report on this. But I'll
Okay.
just tell you off the top of my head, JavaScript, 100%, and
Okay.
there's no surprises there. JavaScript is so easy to use. It's a lot of people's first language. It's
Mm,
a lot of junior developers will pick it up. There's been a lot of buzz and excitement around it on full stack. And so, as I said earlier, the kind of more junior developers are going to have more bugs, but also the language features
right.
that seemed like a good idea at the time. I think the world is moving away. By the way, I love JavaScript. I think it's a great language.
Right.
Bugsnag's front end is actually moving from JavaScript to TypeScript, which is,
Okay. Yeah.
in my mind, just a way to make JavaScript more sensible. It's
Right.
still JavaScript,
Right.
but all of the dirty things that you can do with JavaScript get people in trouble big time. Just even like equivalence relationships and equality relationships and
Right.
magic casting that's
Yeah.
happening. And I think that it's important for people to understand the fundamentals of typing, even in a
Hmm.
language like JavaScript, where it's magically typed behind the scenes.
Right.
But yeah, it can get you in a lot of trouble.
So actually, there's also this question that, I sort of have to ask, leading up to this is, since you talked about, like, say, now you talked about JavaScript being something, looking at your data, that it looks like something that, produces a lot of bugs. Can I extend this question and say, is there a class of bugs coming out of a certain type of, architecture or something that causes more issues. Like, certain things are like, oh, there are no bugs in, say, I don't know, this if you're writing, I don't know, like some IoT software, I don't think there's really any sort of bugs coming in that. It's not as susceptible to, say, a web-based development. Do you see things like that? Is there some sort of analysis that really helps? Like, you start a project and you already know, okay, this is, if I'm choosing this particular architecture and this particular design pattern, I for a fact know that I'm going to have more bugs.
Yeah, I feel like I don't have any data on this, but from my experiences, I can say that the smaller the scope of your project and the better the contracts between your project and other projects,
Hmm.
the less likely it is to have complicated, confusing bugs. And so, this has kind of been really highlighted by the rise of microservices
Right.
architectures, right? You're saying this app does one thing and it
Right.
owns this data and it does this one thing really, really well. And so when you're saying this is the one thing that this service does,
Right.
you can anticipate all of the problems that can arise a lot easier because you're not trying to map a whole complex state machine in your head or whatever.
Sure.
And so I'm oversimplifying this, but if the more you go towards microservice land with contracts between services and applications, I think the more it forces you to document things and think about the relationships between these applications and think about errors that are going to occur that
Hmm.
could cause that contract to break down with
Hmm.
other services. The contrary to that, I think that interactive user interfaces
Yes.
tend to be the most likely to have a lot of bugs in
Right.
because you're building something that is going to be interacted with by people in a lot of different ways and maybe a lot of ways that you don't anticipate.
Right.
And also, there's a ton of asynchronous code running. A lot of your code, most of your code in a UI application, a web app or a desktop app or a mobile app, is running in callbacks. You're waiting
Right.
for someone to interact with your application.
Hmm.
And callbacks can get gnarly sometimes. You were expecting some data to be present that's not present yet at the time someone that clicked a button, or maybe your callback JavaScript's really funny because if there's an exception in a callback, it doesn't kill execution for the rest of the application. It just causes that callback to fail.
Right.
So from your customer's experience, the whole application keeps working, but just your callback, your click handler might break. And I've seen this when on a news website or something like that, and try to click through to the next article, and I'm like, why is nothing happening here?
Right. Right.
So yeah, I think it's about well-defined
Right.
concepts and
Bound.
ownership and
Sure.
contracts. So
Sure.
that's what I've seen.
Yeah, that's like, yeah, good design would really have a good bounded context, and so, yeah, you can reduce bugs. Yeah, that makes a lot of sense. I guess also in terms of, our sort of whole UI development, there are a lot of, third party off the shelf components that we use, right? Like, any of the new JavaScript frameworks or whatever. Like, we have TypeScript, and of course we also have like these different Angular, Vue front end
Hmm.
things with a lot of, third party libraries. Now, what happens to, bugs coming from your third party libraries? Now, that's something that oftentimes, of course, you do you could check for vulnerabilities and things like that, in terms of security. But how do you handle those kind of bugs? Any, like, the third party that you're depending on?
Yeah, it's difficult because
Hmm.
I mean the good news is that most people are using open source third party libraries these days, and so
Right.
you like when I started my career that wasn't the case. You'd pay Oracle for some SDK, and you'd never be
Right.
able to see the source code for that. And
Right.
these days, most providers are making their third party code open source, and so it's annoying because you shouldn't have to deal with bugs in third party code, but the reality is you will.
Right.
And if it's open source, at least it gives you the ability to go and dig into it. And so, if you're using an error reporting, an error monitoring solution like Bugsnag, it will show you the stack trace. It will show you the line of code that caused the crash, and it will show you all of the other code paths that customer went through up until the point of the crash. And so, in that case, you can see, hang on a second, this went through this weird file in React that I need to dig into.
Right.
Or if the top of the stack trace was in the React app, you're like, wait a minute, it should
Hmm.
not be crashing inside of the React library.
Right.
But I think that to avoid that, you don't lead life on the bleeding edge. Try to. It's very exciting to get those hot new features out
Right.
of your library, but don't immediately bump your dependencies as soon as
Right.
some beta is out for a new version of React or whatever it is. I also think that actually selection of third-party libraries is a really underrated part of software development. I think sometimes people are like, right, I don't know, what's a good example? MD5. I need to generate an MD5 hash. So I'm
Yeah,
just going to go on Node, NPM, and search for MD5 hash, and maybe I'll pick this one. But in
exactly.
reality, I want to pick this one because this uses the new Promise interface, and therefore that's really cool. Well, is it maintained? How many stars does it have? And
Right,
on GitHub, are pull requests and comments being addressed and issues being addressed on GitHub? Like,
right,
it's actually, I think people jump to, oh, someone's already written this code, let me use it. Just like
right.
some developers would jump to, like myself included, jump to Stack Overflow and have a look at a
Yeah,
code snippet. But in reality, if you're going to be relying on something, you need to really trust it. And so doing that research on those third-party libraries and SDKs is super critical and very underrated. And my co-founder says this all the time. He'll say he looks for a safe pair of hands. And in third-party SDK land, safe pair of hands might mean the one that's been around for 3-4 years
right,
rather than the one that's just been launched that's growing very quickly. We
right,
can refactor and use that other library if we want in future if it becomes more stable. But right now, who knows if it's even going to exist in a year's time.
right.
So I agree with that approach as well.
Right. I think yeah, that's. I think what you've said has really hit the nail on my head. In fact, I think I also sort of just jump and pick up the very first library. So, I think that really is quite underrated, as you say. So now that we've looked at sort of major causes of bugs, and then we've compartmentalized it also in the sense like we've got third party bugs, and then because of maybe somebody new to a particular language causes errors, things like that. And also we've also looked at bugs maybe because of unrealistic deadline, we just want to get straight out into the market. It's fine. So we've got a whole sort of class of bugs that we've talked about right now. Let's just switch gears a bit, because I found this really interesting article on your blog about these worst bugs in history, right? And we'll have a link in our show notes for our listeners. But would you be able to sort of give us an example of something that you've researched which you think was like, oh my god, I really need to talk about this in the show? Do you have anything like that, like an example that just pops out?
Oh, I mean, the worst one in my mind is the Therac 25 disaster, and this is
Okay.
actually I did a math and computer science degree, and one of the courses I did in computer science was safety critical systems, and they start off not by talking about how to work and build safety critical designs. They start off by telling horror
Right.
stories. And this was one of the horror stories. And so Theric 25 was this story and incident about a radiation therapy machine
Mm-hmm.
that was designed to treat cancer patients. So it was designed to help people. And obviously, it's not just a piece of machinery, it had
Mm-hmm.
software in it. And for whatever reason, there weren't enough safety features in the software, and it led to 3 people unfortunately dying. And so, software bugs actually cause
Mm.
people to die, and it's kind of terrifying because they were thinking about safety criticality while building this software.
Mm.
But this was in the 80s, and in the 80s, this wasn't a super well understood space. They probably weren't teaching safety critical systems in
Right.
colleges back in the 80s. And it's a really weird bug as well because it wasn't a pure software bug, it
Mm.
was a multi layered bug. So they kind of rolled out a new version of this machine. And as far as I understand it, in the new version of the machine, they removed a hardware safety feature,
Okay.
and it was intended that that hardware safety feature would be replaced by a software
Oh
safety
God.
feature.
Okay.
So it's not like that there was a crash or a line of code that had the wrong variable in it or whatever. It was a design bug in the difference between the hardware team and the software team's understanding of how this should work. Obviously, this led to the tragedy of people dying. The machines were recalled by the FDA, but also looking at the other side of things, this has led to a lot of changes in the way that we develop software. And maybe I wouldn't have had a safety critical course at college if it wasn't for situations like this.
Right.
I actually ended up after college working in as a software consultant, and one of the projects I worked on was a high volume medical pump.
Okay.
It was for treatment of patients that had AIDS,
Mm-hmm.
typically. and it was high volume doses of fluid. And it's incredibly dangerous to get that wrong. If you deliver too much of the drug, that's game over for patients
Right.
potentially. And the system that was designed that I was working on actually is a small box about the size of a lunchbox. It had 3 CPUs in it.
Okay.
It had a UI CPU, which is the one I was working on as a graduate software engineer. And so the worst case scenario on that is that it could show up something wrong on the UI, which is still really bad. If you're saying that this much fluid had been delivered, but actually under the hood less had been delivered or more had been
Wow.
delivered, that's a mismatch. But the other 2 CPUs were different layers of safety criticality. And so the super greybeard expert men and women working on the project for the most safety critical CPU, that had to go through multiple audits, independent audit and external audit. And so there's so many layers these days of safety. And as a graduate software engineer who'd only ever worked on like hacked up web projects
Yeah.
really before then, I was like, wow, this is very slow to do anything on this. We have to send it out for review. And then you read about and learn about things like Therac 25, and you're like, yep,
Right.
okay, this is why
Right.
we do this. It's very important to
Right.
get it right. So yeah, it's a horrible story, but I feel like I feel like there was no malice. It wasn't someone trying to do anything wrong. It was just a design problem, and I think lots of safety critical systems have learned from that experience since then.
Right. And design, of course, plays a really important part. And also, I guess the one that you brought out, reviews as well, right? Yeah. Yeah. I think reviews also make a sort of, they are probably underrated as well in reducing bugs. I guess we can switch gears to something a little bit lighter after that example. I guess for our listeners, like in the microservices world, which is what we're all doing right now, interesting to also talk about the Facebook API bug that you had written about. Uh,
Mm.
could you tell us about how that unfolded, and how many clients it affected? And if I remember right, it was something simple like the return type from the endpoint, right?
Exactly right. Yeah,
Yeah. Okay.
this is one of these things, and I understand that this is my company would not exist if bugs didn't happen, right? So bugs happen.
Right.
It's important. It's important to deal with them, but like
Yeah.
I'm not sure if everyone's familiar with this, but if you're a mobile developer, you probably know about this. A few months ago, pretty much every application that used the Facebook SDK, which is most consumer mobile applications, it turns out, started crashing. Some of them crashed on boot, which meant when you went to open your Spotify application,
Mm.
you couldn't open it. It would just crash immediately on boot, and this is on iOS. And this you asked earlier about the third-party SDKs crashing. This is
Right.
exactly what happened. And so anyone who'd embedded the Facebook SDK, what was happening is the Facebook SDK powers things like Facebook authentication, but it also powers things like partner data sharing and things like that. Seeing which friends are listening to certain tracks and features in various pieces of software. Anyway, the Facebook SDK goes off and fetches data from Facebook's API. It grabs it in JSON format. That JSON payload comes back to the SDK, and then some Cocoa iOS code unpacks that JSON and tries to do something with it. Now,
Hmm.
it's a pretty common workflow. Probably everyone who's listening has done something like that. Now, obviously, if the data that comes back is not in the format that you expect, you should protect against that. In fact, that's exactly what you asked about the first question, pretty much is what are the
Yeah.
common bugs? Not protecting against unexpected situations.
Right.
That's exactly right. And in this Facebook SDK, what looks like happened was that either intentionally or unintentionally, the team that powered that API that was returning that JSON payload changed the structure of the data in that payload. And okay, fine, that happens, right? That's going to cause a bug if you change the structure of that data without having the new format supported.
Right.
But in this case, it wasn't just the bug where some information was missing, it caused a crash. So the Cocoa code was expecting to dig into a particular variable with a particular structure. So it was doing operations on a string that
Mm.
it expected to be an array or a list, I think was the way around it worked. And so unprotected access of the wrong data type caused the whole piece of code to crash. And in a Cocoa application, in most applications, that then caused the entire application to crash because it was an unhandled exception that bubbled out from the SDK and then was not caught by the application code. And so what a lot of the time bugs are introduced when you change code. So if you roll out a new release or a new version, you're going to be looking very carefully to see if there are new crashes introduced. But if you are Spotify and it's 3 a.m. and Facebook pushes out a new change to their API, you do not expect 100% of your sessions to fail on iOS, which is what happened. And so it's a nightmare situation. Right. And really the impact of this was huge. It was pretty much most major consumer mobile applications on iOS had blips of outages for a number of hours. Now, the impact was also kind of insane for a product like Bugsnag. And so our product detects bugs, crashes, and exceptions in people's software, and then gives you the data that you need to figure out what's going on and how to fix it.
Okay.
So effectively, and we have a lot of customers that are in the mobile space and especially in the consumer mobile space. Okay. And suddenly we got a ton, tens, hundreds of millions of exceptions being reported to our servers. So we're just, our servers auto scale and our systems auto scale, so it wasn't a problem. But suddenly my infrastructure team saw this big spike coming up of all of these consumer mobile applications on iOS sending exceptions in. And in fact, one of the leading exception handling providers, error monitoring providers for mobile, Google's offering, could not cope with the volume, and in fact basically shut down their servers for a while, or at least stopped processing a lot of the data. So, because effectively it's like you're getting a denial of service, right? You've got all these clients around the world sending in all of this data at a much higher volume than you expect. Right. So that was bad, but obviously bugs happen. And what we say at Bugsnag a lot is, don't anger the ops gods. So if your competitor or someone you know about software goes down, never gloat about that, right? Never ever gloat about that. Be like, "Ooh, I wish I'm glad it wasn't us," but because if you anger the ops gods, it will come back to you next week. Right. You'll have an outage as well. But the thing that really bugged me about this was a few weeks later, the exact same bug happened. So they changed again the data format again. Wow. And the exact same bug happened. So look, make a mistake, learn from the mistake.
Yeah.
And I think it was Facebook used to say, "Move fast and break things" was their motto. And kind of fine, sure. Learn from these mistakes though. And the second time it happened, was there no change control there? Who allowed that API change to happen? That's the thing that I think annoyed a lot of developers, because they're like, they didn't even have time between the first incident and the second incident to put in more protective code paths to stop this from happening and SDKs from blowing up their application.
Right. So actually, I guess a lot also, I wonder about things like, API stability that, usually have rules for that, right? I mean, I guess there's generally a period of time before you tell your clients, hey, we're changing something that's going to really break things.
Exactly. Right. It must have been unintentional. I think that I think it was a private API. Okay. Which maybe they were less careful about, but it must have been unintentional, I'm sure. Okay. But yeah, it's, what's interesting is that, and again, you never know what goes on inside of a company when there's an outage going on.
Right.
Our customers knew about this outage seemingly hours or at least 20 minutes before Facebook did, because one of the things our service does, it will tell you what percentage of users and what percentage of application sessions are healthy or not. And so when you're at like 99% healthy and then suddenly it goes to 0% healthy, it's very straightforward to see that in a product like Bugsnag. But yeah, all the GitHub issue, then people went to GitHub issues for the Facebook SDK and started saying, "Hey, this is down." And engineers were responding with, "Oh, really? Let me look into this for you."
Wow.
Who knows what was happening, but maybe they were scrambling to get it fixed. They probably were. They probably have really good monitoring in place. But one time, okay. Second time, happening. Woo.
Right. And I guess it also brings out how important it is for, I guess, teams to also protect against their third-party SDKs, like you say. I think that's again one area where you really need to focus on how how your application reacts to that.
Become an autonomous digital enterprise and your business can achieve A-game status. Intelligent predictive systems, effortless automation, and technology and people working in harmony. This is the Autonomous Digital Enterprise. Visit bmc.com/agame for more information.
Okay, so that's like some. I guess we've got sort of a look at how bad bugs could be. If they happen, like we've got the really serious ones that you talked about, which could be life threatening, and then of course you've also got like your day to day things, like your favorite app doesn't open up because of a crash, like what we just discussed. I guess now, sort of logically, I'd like to move a little bit into another area of software quality. So there was a show in 2017 with SE Radio. I think it was episode 280 with Gerald Weinberg, and he had a book. I think Bugs, Boo Boo, and Blunders. And when he was actually talking on the show, one thing that really struck me as a listener was. I think the anecdote that he was giving was he was at a car a car manufacturing place where there was an auto show. I think, sorry, it was an auto show, and there was this new version of the car which he was looking at, and it was great, like when he was looking at the brochures and stuff. But then actually when he went into the car and started driving it, that's when he really felt the car and found out things about it. And the analogy was the same thing with software, that you actually really know the major issues in your software only when it's in the hands of a real user.
Yeah. Hmm.
So in a way, I want to know, are there a sort of class of bugs that can only be found by actual users in the field?
Yeah, I feel like I kind of touched on this earlier with the fragmentation of devices. That's one that
Right.
is particularly painful. I remember when I started my career, I like to think of the phases of bug remediation
Right.
being before in the hands of your customers and after. And it used to
Right.
be there's this big phase in between
Right.
where it was human powered QA. So when I started my career, huge QA teams would work for sometimes months on
Mm,
going through a QA script and QAing your software. And the
right.
more that we've got to lean agile, rapid iteration, and being able to hotfix and patch things and componentizing your software, we can ship faster. And so that doesn't work anymore. You cannot have a team of humans do 2 months of QA.
Right.
So from the left hand side of software development, that's kind of been replaced with this. I think it's Capital One call this team quality engineering,
Right.
which I really love as a term. But it's basically saying, look, let's not have people going through Word document scripts and clicking around on the application and typing in weird characters. Let's try and automate that as much as possible.
Mm,
And then from the right hand side, you have data driven instrumentation with products like Bugsnag that will tell you, yes, this is a problem. This is how many customers is affected. This is how you go and fix it.
right.
But what's funny is, and I said this earlier, that if you could get that perfect vision from the left hand side and get everything fixed, our company wouldn't exist and our business wouldn't exist. So thankfully bugs exist in the hands of customers. But yeah, I think that the ones that end up happening in the hands of customers tend to be where the data representing that user has got into a strange state. So
Okay.
I think typically when you think about pre-production and pre-customer testing,
Mm,
you've got this like unit test and integration tests. You've got these like clean room environments
right.
where you start from the memory in your application being completely blank. Then you
Mm,
start up the application, and then you click around and do X, Y, and Z things.
mm, mm,
And in reality, customers have quite a dirty environment they're running in.
mm,
Because you need to do things like save state and make sure
right.
that you're caching things and making sure that you're authenticating the customer. And
Mm,
so you don't start off in this clean room environment that you do in integration and
right.
unit tests most of the time. So I
Right.
think that most of the bugs that I see that happen are not due to necessarily code paths being missed, because
Right.
in theory you should have good code coverage in your testing.
Right.
It's about weird data structures and weird unclean data coming through. I mean, we had at one of my previous companies, we had a bug that was caused by a corrupted cookie format in a migration between two types of authentication token. There was a bug in that migration,
Okay.
and it caused a large percentage of customers to have a bad authentication token. And when the application was trying to read in that data,
Okay.
it would just kind of blow up because it was expecting that it could be to be called auth or something like that, and it was all corrupted. And so you're not going to think about that when
Right.
that's a really good another example there. Bad like data and caching data that has gone into a
Mm,
layered state, but also I think anything where you're migrating data as well, because
mm,
it's the same problem, but migrating data when you're running your tests, you expect the inputs to look like a certain way, but if the
right.
inputs look different,
Mm,
hopefully your migration will fail cleanly, but if it doesn't, it's going to migrate bad data into worse data. And
right.
so that's I think I've said the word data about a million times there, but I think that's what the gets
Yeah.
the problems that happen in the hands of your customers is where you're not operating in that clean room environment, and there's caching and authentication and cookies and local storage and all sorts of stuff that's stored on the device, and it is probably not in the format you expect.
Right.
There's other things as well, which I think I mentioned device fragmentation.
Yeah. Yeah.
one of
Yeah.
the
Exactly.
one of the
Yeah.
funnest
Mm,
examples of that is I forget which vendor it was, so I won't name and shame, but
mm,
uh, a mobile Android phone manufacturer.
mm,
One thing that a lot of people don't know about Android is that yes, there's this beautiful AOSP Android open source project, but every
right.
single vendor forks it and messes around with it, and you see that from
Right.
the user interfaces. But actually, that forking and messing around with the code happens at much lower levels.
Mm,
And a major mobile phone vendor, in their modification of the Android open source project, modified JSON parsing. And again, we're back to JSON again, just because everyone's using that as an interchange
yeah.
format. But
Right.
they literally modified in Java, you've got what a java.util.json or whatever it is for modifying and reading and writing JSON. They
Right.
modified that. So if you were expecting it in your test environments for it to deserialize JSON in a particular way, in one rare case, it would not deserialize data in the way that every other Android device in the world would. And so, look, you can have maybe you got lucky and had, like, let's say it was HTC, right? Maybe you had an HTC phone and you would have caught it,
Mm,
or you run a device farm and you tested it.
right.
But if you
Right.
didn't, then you have to wait for your customers to tell you that because it
Right.
only happened in that particular environment. So
Right.
yeah, it's the Wild West, especially on client side.
Right.
You don't know what's happening with the environment. You do not control the environments.
Right, you can't really control. But that also brings me up to the question, like, I guess this is more like I mean, it's just your thoughts on it, not to put you on the spot, but is it okay to delegate finding bugs to our clients who paid money for our software? I don't know.
Yeah, people. I don't think it's okay. I think it's. There's a phrase that people use a lot, and I really hate it, which is called test in production. I don't know if you've heard people talking about test in production and embracing
No.
test in production.
Right.
I think that's the wrong way of thinking about things. I think that either you are very intentional about trade-offs to mean that maybe bugs will
Yeah.
happen,
Mm, mm,
or
mm.
you have to be like, well, that sometimes bugs are going to happen, but we want to use tooling and technology to
Right.
remediate them as quick as possible. And
Right.
so, yeah, I remember when I was talking about QA earlier, when I started my career, the QA
Yeah.
engineers, the QA team at one of my
Yeah.
companies I worked at, would go through scripts and they would do things that, that you'd fail the QA script if if your username was 20,000 characters long or something
Right.
ridiculous. And you're like, these days, I'm like, who cares? Like, if a customer is typing in a 20,000 character username, are they really a customer that we care about that much? Like, does it really matter? And it's such
Correct.
a brutal way of describing it, but I think that QA ranks mostly, maybe you have a P1, P2, P3 priority system, but it's very blunt about how it categorizes and prioritizes bugs.
Right.
If you are measuring at the bare minimum, if you're aggregating bugs by root
Mm.
cause, then you can
Yeah.
at least say this bug is affecting 100
Mm.
people and say,
Mm.
we've got to fix that straight away. So I
Mm.
see this as a way to better allocate your resources effectively.
Mm.
So if you've got a small
Mm.
engineering team, use that information to quickly get in and fix that bug. And which bugs matter the most varies by company as well.
Mm.
I've given a really basic
Right.
example of how many times it's happened, but
Mm.
uh, the way that we've built Bugsnag, we allow you to attach metadata, diagnostic data to any crash report. And
Mm.
some key use cases for that are, look, show me bugs that are affecting key customers, people who are spending more than $1 million a year with us, if you're a B2B company or a big company. Or show me bugs that are happening in a really important flow, like login or payments flows or whatever they are. Because if you do have those scarce resources, like every engineering team, development team does, you probably want to fix the bugs that matter the most first.
Right.
And maybe if people are typing in 20,000 character usernames in a settings page, you can leave that one. You can put that in the backlog in Jira for a while.
Okay. Interesting. Yeah, it makes perfect sense. You rather, focus your energy on the paying customers as well. Yeah. Uh, like the big clients, the big ticket. Yeah.
Yeah. Or the one, the highest pain as well. Like if you are
Right.
if you're a consumer mobile application that doesn't have like people spending a lot of money, you
Right.
probably want to focus your time on the bugs that are affecting the highest volume of customers as well. Like
Right. Of
whatever
course.
metric you want to use in your software, just be thoughtful about it and use data to drive it. And then I think you can deliver software that's just as stable as if you did a 2-month QA process, and
Right.
in fact improve it quicker and get features to market quicker.
Right. Okay. I guess I'd like to revisit that a little bit later in the show. But I have this question also about we talked a little bit about you just briefly touched you talked about this resources that apps use. For example, if you're having mobile apps, there are so we had an episode on mobile usability a few weeks back with Matt Lacey, and he had this he talked about 6 principles of usability, and one of the principles was like resources and how apps use resources. And he said there are certain apps which actually lose out because of the way they manage resources. For example, you're using something, your phone really heats up, or battery is like discharging like crazy. Do you have any, like, I'm just curious, do you have any examples of where you might have seen, because of this kind of problem, where the apps were not really good in actually managing their resources on the mobile phone, then they actually lost out to the market share, and then people just like started uninstalling that app, and yeah, I'm not going to use it.
Yeah, there's a classic example of this.
Okay.
It's a class of examples, I think. But
Okay.
before I go into that, I think there's something interesting in the web services world.
Okay.
People talk about reliability, and
Right.
you'll hear like job titles like site reliability engineering.
Right, of
And
course.
reliability, it's if you go and read I love it. The Google SRE book is great. I
Yeah.
actually think it's very well written.
Mm,
If you look at what the definition typically of reliability is, it's kind of 3 layers, and I think of it as like a pyramid, right? So
mm, mm,
availability,
mm,
are my servers and services even running?
mm.
Stability, which is mainly what Bugsnag focuses on, and then performance on the top.
Right.
And if any of these are not working correctly and not hitting your SLAs
Right.
that you've defined,
Right.
you're going to deliver a poor customer experience.
Right.
And the one you're talking about here, I think, is mostly on the performance side
Right.
of things,
Right.
effectively.
Right.
But actually, a lot of the times, these performance issues do end up in stability issues.
Mm-hmm.
So there's this really classic example, and I think that there's plenty of great third-party open source libraries now to help you not make this mistake.
Right.
But when I first started off in my mobile development career, when mobile development was brand new on smartphones, at least,
Yeah.
almost every app that was being built,
Yeah.
if it had content in it, you would do the infinite scroll model, right? So
Yeah.
you'd load some data from an API and then show it on the screen, and then as the user kept on scrolling. So imagine Instagram, you're scrolling through all your pictures on Instagram.
Yeah.
Now, one of the classic problems that happen in these infinite content, infinite scroll environments was you're great at pulling in data from the API, you're great at allocating memory for that, or maybe
Yeah.
Java does it for you automatically or whatever.
Yeah.
You're great at rendering it on the screen.
Yeah.
But what happens when it goes off the screen? And so there were so many apps in early mobile development that didn't think about the resource allocation
Right.
of off-screen items and off-screen things on the menu. And this is true actually with web apps as well. With things like React, you want to make sure that you're rendering things that are in the viewport.
Yes. Yes.
But anyway, on mobile, if you're Instagram and you're downloading images that are 0.5 megabyte to 4 megabytes in size, and
Yeah.
you're on a mobile device that has hardly any RAM,
Right.
you need to really be good at this.
Right.
And so you ended up having this. Anyone who had an Android phone in 2009 or 2010 would be able to really understand what I'm talking about here. Android used to feel like you were going at 3 frames per second, right? It used to feel like you were in a stop motion movie. And it was because the core operating system wasn't super performant for things like scrolling, and they thankfully fixed that.
Right.
But also because there were no really clean patterns or libraries or
Yeah.
SDKs for helping you manage resources when they went off screen. And so, yeah, I'm having flashbacks a little bit to that because it was so awful that
Right.
it was not the experience you wanted on a buttery smooth mobile. Like you had an
Right.
iPhone and an Android next to each other, and
Yeah.
one of them was a beautiful buttery smooth experience, and the other one was a jerky experience that ended up crashing because you had an out of memory error when all of these images were in memory.
Right. Yeah. So I guess so. So now that we've sort of looked at all of this, I think towards the end, like we're sort of going towards like my final part of the show, and I guess I want to spend some time on how we should deal with buggy software. So I guess you have like sort of touched upon it through our talk, but if I were to like sort of summarize it, one of the things that we're talking about is like, for example, we talked even about this Google SRE book. There's this thing that they have, that error budget, right, where they say that if you don't hit that error budget, then maybe you shouldn't be spending so much time on all of these different testing and things that you're doing, and then work on features. Should teams be actually doing that, or that's number one. The second thing is, should we actually, if that is what we chose, should we like sort of double down on our QA effort if we have an error budget? And the third thing is, do you just like you say in the beginning, just live with bugs and maybe just have a sort of triage it, rank it, and then based on the ranking you try to fix based on whatever criteria you've chosen? What are the in your mind, like the top couple of things that teams should be doing, or companies should be doing actually?
Yeah, I think actually your flow that you've laid out there is a really sensible framework for this. I think that you need to measure,
Right.
you need to then benchmark and have rules of engagement for what happens if you're not hitting your SLAs, SLOs. I'll talk more about that in a second.
Right.
And then you need to have the process,
Hmm.
and the people need to buy into the process as well. So
Hmm.
let's start right back at the measuring point of view. So as you said, in web services, web applications, in SRE land, error budgets, which typically means the number of 500 errors or 50x
Yeah.
errors that you're seeing, is a really good metric of that. Now, what we've done at Bugsnag is we've extended that concept to any application. So we have this concept of what we call a stability score. And so once you've installed Bugsnag, you drop in our SDK, we'll detect any unhandled exception, signal, out of memory error, Android not responding, application freeze, whatever it is, anything that causes your customer to end in a failed session. We'll detect that scenario.
Okay.
And then because we know how many sessions there were, we've counted the sessions as well. We've got a fraction. We can say, out of, it's like an error budget, same thing. Out of 100 sessions, 99% of them were problem free. And so out of that, you get a nice percentage. You say, okay, 99% of my sessions were good. My stability score is 99%. But you can't just start there. You can't just have that and be like, okay, great. You need to do something about it if it changes. So the next thing I think you need to do is decide on what an acceptable range of stability scores is, or error budgets are.
Okay.
And we take the approach in Bugsnag, same as in the Google SRE book, of allowing our customers to select not just one goal, one target, but actually two. We have an SLA goal and an SLO goal. SLA goals, the service level agreement goal, is, look, if your stability score drops below this number, then treat the world as on fire. You'd stop everything, you drop everything you're doing, and you come and get that stability up to the area it needs to be. For example, if Facebook's API returns the wrong data format, you need to figure out how to get your application booting again.
Right.
But typically, most people will be above that SLA. And then the next goal is an SLO, a service level objective. Now, service level objective, the way we see it, we call it a stability target. Your target stability is more aspirational. It's more like, okay, look, what are our peers in the market doing for this? And where do we want to get over time? And so the sweet spot then is, in theory, if you set those SLAs and SLOs correctly, is to be somewhere in between the two. And the sweet spot is to have those lines get closer and closer together over time as you get more understanding about the quality of your application.
Right.
And so setting those SLAs and SLOs is not something you just do as an engineering team. You need to talk to your business counterparts or your
Right.
product team counterparts.
Right.
And once you've done that,
Hmm.
you end up with this really great symbiotic relationship forming between the product team and the engineering team, where I'll give you a great example. One of our customers in the hospitality space, they were launching a premium hotels feature.
Mm-hmm.
And during the launch of that premium hotels feature, they dropped below their critical stability. And so they actually discussed, they told me they discussed in a board meeting
Mm-hmm.
that, hey, board of directors, I know you're excited about this premium hotels feature, but we're not going to ship it on time, and this is why. And it wasn't the engineering team saying that; it was the product team saying that. So you've
Right.
got this like buy-in between the two parts of the R&D department, for lack of a better word, of
Right.
like, we agree that this is going to be a negative customer experience if we drop below this number, and
Right.
so this is what we'll do.
Hmm.
So that is really important. What do you do about it is the kind of the final piece of the puzzle, I think, as you alluded to.
Right.
If you've got targets, you've agreed upon, you're measuring, you have targets that you agreed upon with the product team. What do you do about it next? Well, there's a bunch of approaches here. The old way to do things, like with QA,
Right.
would be to toss problems over the fence. And some companies do this, and that's fine. What I mean by this is having a team of developers that just fix bugs. Now, I don't know how many developers you've met that are super excited about spending all their day fixing bugs. They definitely exist. I have met them before. I have met them,
Okay. Please introduce
but
me to
it's
them.
not. Yeah, it's not the norm. It's not every developer for sure.
Yeah.
I think that builds the wrong. This is subjective. This is my opinion now, but I think that builds the wrong attitude in an engineering team. I think that
Right.
what you're seeing trends wise more and more is that the code that you write as a software engineer, you own for a long
Sure.
time. You
Sure.
don't just build it, and it's like back in the day, you used to, when you shipped Microsoft Office, they'd print it on a CD and you'd ship it to Best Buy and someone would buy it from the store. Like,
Right.
that's not how it works anymore. When you've written code, you're going to see that code again,
Right.
probably tomorrow. And so having ownership after things go to production,
Hmm.
I think is a critical mindset for software developers. It should be obvious, I think, to a lot of
Yeah.
listeners, but I think it's a critical mindset to have. And so having another team that fixes bugs, I think is a bad idea.
Right.
One, in terms of actual positive approaches, I've seen two that work really well. One of them is ownership based on who touched the code last.
Hmm.
So if you see a bug comes into production, it's been prioritized based on using Bugsnag's rankings or whatever you're using, or someone in Jira has ranked it up to the right level. Then ideally, the person who touched that code last is going to be the expert in that area. Now, that's not always so straightforward, because it might be that someone did a commit that changed all tabs to spaces in the entire code base. And now their name's all over the whole the whole code
Right.
base.
Right.
But if you use git blame, it will tell you who last touched the code, and maybe that's a good way to assign things. Now,
Right.
a better way of doing it that is less granular
Hmm.
is what team owns this code base. Now, a lot of teams are migrating to using GitHub's code owners file format. I'm not sure if
Hmm.
you've seen this, but you can define now in a file
Hmm.
in your repo,
Hmm.
this is who owns
Right.
this part of the code base.
Yeah.
So it's less finger pointy then. It's not like, oh, James changed tabs to spaces and now he made this bug. It's more, this team is responsible for this area. So I think
Hmm.
that's a really good approach.
Hmm.
An alternative approach, if you haven't yet adopted those techniques, is to do. I think Airbnb call it bug sheriff, or we used to call it bug warrior at Haze
Okay.
App, my previous company.
Okay.
And the idea is that you're on rotation.
Okay.
So you and probably a buddy, an engineering buddy, are going to be responsible for triaging, prioritizing, and fixing bugs on a rotating basis. And really, this shouldn't be too frequently. You
Hmm.
should set up the rotation such that you're only bug warrior 1 out of every 5-6 weeks at the
Okay.
shortest time period. But the idea here is that you, hopefully, it might not be code that you've written, but it does give you empathy for other parts of the code base. So
Right.
it still gives you empathy and ownership around the software that you're delivering to your customers.
Right.
So it really depends on how sophisticated you want to be, but I think you can't actually triage and fix bugs effectively unless you commit to a process for doing so. And they're two really good techniques I like for doing that.
Right. So I guess to sort of summarize first, obviously you set up like benchmarks, measure it, look at the data, and then, rank by however either you're using your software or whatever your favorite thing, or somebody goes in and ranks it. And then, of course, then the part about who actually goes and fixes it, instead of blaming it, sort of assign it to a team member, to an entire team, and do like various approaches, like you said. I like this bug warrior, that kind of thing, and then go and fix the bugs. So, and also, and like one important thing is the person, like the team who wrote the code should be the ones who fix it, so don't like toss it over. I think that's pretty much what a lot of companies are doing, but yeah, it's good to sort of reiterate that through this.
Well, I tell you what, the one thing to
Yeah.
definitely not do is to wait for customers to complain. And I
Right.
think that no matter if you're using Bugsnag and you've got a bug warrior, and if you've got great Jira triage or whatever you're doing,
Right.
like, be data driven. It's not that hard to adopt a data driven approach to prioritizing and fixing and remediating bugs. So,
Right.
like, yes, there's great tools out there but even if you want to build your own stuff or make your own algorithms or rank them your own way,
Hmm.
don't wait for customers to complain, because by the time customers have complained, probably 50 other customers have already left your product.
Hmm.
So that's the thing that I still see a lot of teams doing, and it scares me when I see that.
Hmm. Okay, this is great, James. I think that's probably all I have. I guess I would just, before I end, I was wondering if you could again tell me a little bit about that stability score, because that's one thing that is that how do you do that? Could you just like sort of reiterate, because that was really, that piqued my interest. So can we just like go over that
Oh,
again?
okay, yeah.
Yeah, yeah.
Yeah, so effectively, we want to help people understand what percentage of user interactions with your product
Okay,
succeeded or failed.
okay,
And to break it down a little bit more specifically, let's say you're in a JavaScript application, a React
right,
application.
right.
We will detect if there are unhandled exceptions. We'll detect if there are unhandled promise rejections, or we'll detect if there's an exception that was in a callback, like I was talking about earlier. If any
Okay,
of those situations happen,
yeah,
or if you're using a framework like React, we'll also detect errors that bubble up to a React error boundary. And
okay,
so, depending on the platform, we have basically built these hooks to hook into failure states in your product.
okay,
So, sure, these are still going to cause your customers to have a bad experience. Our product doesn't magically stop bugs from happening, but it will detect when they happen. And then that all feeds into the stability score. So if your session had any of those scenarios happen, that
okay,
counts as a failed session. And it's
okay.
different techniques on different platforms, but it's always the same underlying concept. I want to know which customers had a positive experience, what percentage of that customer base. So
Okay.
that's how we calculate it. We've got an article on our blog about this as well that
Okay.
talks about it a bit more in depth.
Okay. That's really interesting. So again, yeah, I think this is a great conversation. So thanks, James. I think this probably ends our session. But if listeners want to reach out to you, is there a Twitter handle that they can reach out to? Would you like to?
Yeah,
Yeah.
I'm not super active on Twitter, but I
Okay.
do check my messages. I'm at LoopJ, LOOPJ,
Okay.
and I'm also on LinkedIn as well. You can find me. I'm James. James Smith is a very common name,
Right.
but if you type James Smith Bugsnag into LinkedIn, you'll find me pretty quickly. And
Okay. Fine.
also, bugsnag.com is our website as well, and I've
Okay.
got plenty of blog posts and things on there as well.
Okay. Okay, thank you very much. And this is Priyanka Raghavan signing off for Software Engineering Radio. Thanks for listening.
Become an autonomous digital enterprise and your business can achieve A-game status. Intelligent predictive systems, effortless automation, and technology and people working in harmony. This is the Autonomous Digital Enterprise. Visit bmc.com/agame for more information. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.